Hello, Chemistry 11. This is Mr. Chan. And recall the last video, we talked about significant figures or significant digits. And we talked about the 5 rules in determining significant digits. And how did we figure out the number of significant digits or important digits that were in a measurement? Now, the reason why we need to be aware of significant figures or significant digits is because when we measure something, there's always going to be error. There's going to be error in the equipment that we use or even in our guessing. So that's why significant figures or significant digits are important. Now, we also talked about some rules with significant digits. We talked about multiplication and division. And how do we use significant digits in this scenario? And we also I gave the example about addition and subtraction. All right, and how do we consider significant digits in this scenario as well? But there is a situation where there is no significant digits. There is no uncertainty in our measurements. And in that scenario is when we have exact numbers and conversion factors. Now, these are considered to have infinite sig figs and therefore do not affect calculations. Now, exact numbers and conversion factors basically have no uncertainty. For example, there's exactly 1,000 meters in 1 kilometers. It's not 999, it's not 1,001. This is a set value. Same thing for exact numbers. If I were to count how many apples or how many students, I know exactly how many I have. So when you have zero uncertainty in your measurement, what that means is that you do have infinite number of sig figs and therefore do not affect the calculations. Now, what do I mean by this? So let's say we did a simple example. Let's say we have 450 meters, and we want to change that to how many, let's say, kilometers. Okay, so here we have 450 meters times 1 kilometer all over 1,000 meters. If we were to take a look at the number of sig figs, here would be 2 significant digits. And this conversion would be infinite number of sig figs. So what will happen is my answer should have 0.045 kilometers or 4.5 times 10, oopsie, it's 0.45. There you go. 0.45 kilometers or 4.5 times 10 to the negative 1 kilometers. Now, both of these have 2 sig figs. Okay, because of the 2 sig figs in the original question. And that's what we mean by infinite sig figs, because the 1,000 meters in 1 kilometer, that is a set value. There is zero uncertainty. So the difficult part when you're looking at this type of scenario is when you're taking a look at the number that you see, is it an exact number or is it a measured quantity? If it is an exact number, then there's infinite sig figs. But if it is a measured quantity, you have to apply the sig fig rules. Now, we've been dealing with a lot of math, and one of the things that we should be aware of is in science, we do a lot of graphing. Now, in graphing, there are 2 types of graphs that are used in science. They give a trend or a focus on a specific part of an experiment, or they give a mathematical relationship. Now, generally, there's about 3 or 4 graphs that are commonly used in science. So we have direct, and when you have direct, me see if I can do that here. Ooh, okay, that's okay. What you get is a straight line, and what you have is that it goes through the origin. Goes through the origin. Linear, what you would have is it would look something like this. If I did that, so linear would look something like this. In some ways, you notice here, not through origin. And sometimes we have inverse, or I even would say exponential. Exponential. Inverse would look something like this direction, and exponential would look something like this. So this one would be exponential. And this one would be inverse. Okay, so here would be inverse. So these are the general graphs that you will see in science. Now, one thing that's very different when you talk about math and science graphing is that due to uncertainties in our measurement, the lines on a graph is described as best fit. Okay, so when we plot, whether it's direct, linear, exponential, or inverse, we have what we call best fit lines. Okay, and the line is drawn so that the number of dots above equal the number of dots below. Now, what do I mean by this? So let's say if we were to plot something. So we have our standard graph. What happens is you will get data points that maybe, sometimes not really, consistent. Now, in math, sometimes they tell you, oh, you just connect the dots. You go something like this, dot, 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 dot. Now, this is math. But in science, what you want to do is you take a look at all your data points, and generally, what do they fall under? Do they fall under direct, linear, or an inverse or exponential curve? And so what you want to do is you want to draw a line. If I were to do this, draw a line. And I might say, it looks something like this. Now, this line that goes through the majority of the points, this is what we call my best fit line. Okay, and that's the key difference between math and between science. For math, they assume the points are exact numbers, and so that's why sometimes you connect the dots. But in science, we take into the fact that there is uncertainty, and we want to see what the general trend is in our data. So that's what a best fit line is. Okay. Now, in science, the best fit line doesn't necessarily go through the origin. You need to analyze the data and decide whether a point should be placed at the origin and be used to draw your line. Now, but when you draw a graph in science, it's basically the same requirements as what you have in math. You have your two variables, you have your x and your y variables, x being independent, y being dependent. You want to make sure you have a scale and a graph appropriate for the data, and you have a legend, you have a title, and you calculate slope. So if you were to draw a graph, you know this from math. So you have your y, you have your x, and sometimes you have two lines. So let's say you have an orange line here. You have, let's say, a black line. Let me get that there. Let's say a black line here. What you want to do is you always want to have a legend telling you what lines represent. You want to have a title, whatever the title is, and you want to calculate the slope. Okay. Now, what we have is in class, we will be doing a lab that will reinforce some of the concepts like the graphing requirements, as well as the idea of best fit lines. So please make sure if you can make it to class. All right, thank you very much. Have a good day. Bye-bye.